I'm Mike Chapman from the National Center for Atmospheric Research, specifically the Research Applications Lab. And I'm going to talk today about some applied research that we've been doing in conjunction with the Federal Highway Administration that is interesting for the ITSA conference. Specifically, what I'm going to be talking about is connected vehicle research that we're doing. And what's happened over the last few years is communication technologies from vehicle to vehicle and vehicle to other infrastructures is actually becoming more mature. And the federal government has looked at it as a way to help with safety and mobility and things like that on the roadway. And specifically, they were looking at crash avoidance and automatic tolling and efficiency on the roads. But we also looked at it and said, okay, well, cars are affected by the weather. What information can we get off of a connected vehicle that would allow us a better idea of what's actually happening on the road? So what we're planning on doing is leveraging different connected vehicle data sets across the United States. We're going to take native information off the vehicle, such as air temperature, barometric pressure, but also other things that mechanically change with the weather, like wipers, brakes, stability control, traction control, things like that. And we're going to try and package that together in a smart way in some kind of software with other weather data sources and come up with segment by segment weather impacts to the road. We took one of our own vehicles, it's a Ford van, and we instrumented it. And we also tapped into the onboard diagnostic port, and we're pulling weather information off the CAN bus of the vehicle. What I'm showing here, I wanted it to be fairly simple. This is not an exhaustive list of the things we're getting off the vehicle, but here, for example, this is tracking the air temperature off the CAN bus of the vehicle. Here's an external sensor we added. It's showing you pavement temperature. It's an infrared pavement temperature sensor. We have 2 of those installed on this vehicle. We also have another weather sensor here. It's called AirMar. It's more of a maritime sensor, but it's giving us also verification of temperature, pressure, relative humidity, possibly wind speed. We're working on that. And then down here we have some of the binary fields we get off the CAN bus. Are the brakes on? Traction assist on or off? Are the wipers on or off? We have the speed here. We can get speed, location, elevation from GPS. We have accelerometer data we can also access to get yaw and pitch and roll, things like that. We also have this is an external sensor here. It's a optical friction sensor that we have added to the vehicle. So I'm going to go ahead and animate this real quick and then I'll stop it. We just took stretches of road, and what we did was took observations here, and then we ran it through a software system called the Vehicle Data Translator to give us inferences of what's happening on the road segment. So let me go ahead and start it. Yeah, so it's a little bit jumpy. It's HD and it's a little jumpy because of our internet connection. But you can see all of this data is coincidental. So these are the observations coming off the vehicle. These are the road segments that our software system is making inferences for, and this is the video to verify the output from that software. So you can see here, and this isn't exhaustive either of a list that we get out of the software, but it's interesting, I think, to the folks here. So we can give you an average air temperature, average surface temperature, that's from the external sensors, but we also make inferences here for the type of precipitation, the visibility on the road, and pavement. What's happening to the pavement? Is it icy? Is it snowpacked? Is it slushy? Is it just wet? And I mean, what you can imagine is see these vehicles that are driving by, likely in the next few years, will actually be communicating back and forth to one another, and also communicating their information into some kind of application that maybe uses our software to give vehicles an idea of what's up ahead. You know, what type of roads are they going to expect? Or is there some kind of impactful low visibility event that they're going to encounter? And likely that's going to be in the next 10 years or so. We'll have that kind of technology. Privacy issues do come up every time we talk about this. We are talking about, at least when we're out of the research world and into the operational world, we're talking about autonomous data. So we're not even going to be able to track a specific data point unless it is a public vehicle and they give us access and permission to do that. Likely, if it's passenger vehicle data, we will just get point-by-point autonomous data that will just give us specific things off the CAN bus, and we won't be able to track those vehicles from point to point.